Hello everyone, I am Yuchen Wen from the Institute of Computing Technology, Chinese Academy of Sciences, and I am happy to introduce our paper accepted to ACL 2025 findings named Evaluating Implicit Bias in Large Language Models by Attacking from a Psychometric Perspective. It is collaborated with State Key Laboratory of AI Safety, Key Laboratory of Network Data Science and Technology, and UCAS. There is a warning that some content can be offensive or upsetting and does not represent our standpoints. This is the contents of my introduction, including 6 parts. First, let me introduce you the definition of implicit bias. It is a kind of social bias without explicit harmful words targeting certain social groups. For example, the sentence shown contains implicit bias towards women. It spreads and may cause harm. However, inherent implicit bias in LLMs still lacks thorough evaluation. Psychometric methods are effective for inducing inner beliefs, and therefore can be applied in bias evaluations to solve this problem, making it possible to thorough evaluation bias of LLMs, offering insights to bias in them, and finally helping to build responsible and trustworthy AI. This is our psychometric-based attack methodology, containing 3 main attack methods, which are disguise, deception, and teaching attacks. Each of them leverages psychometric principles from psychology subfields and is based on advanced and foundational abilities of LLMs. Next, I will introduce these attack methods in detail. First of all, disguise attack is based on the principle of goal shifting, which transforms true intent of tests to different tasks to avoid being detected. In our implementation, we leverage conversational tasks to disguise our attacks. Secondly, mental deception attack, which is a kind of deception attacks, is based on the principle of cognition concordance. When encountering new conflicting ideas or actions, reconciliation is often the choice. We ask models to believe in a biased viewpoint and watch if it influences models' following behaviors. Next, memory falsification attacks are also based on the principle of cognition concordance. We forges a biased context to pretend that the model itself has responded biased content and watch if it influences models' following behaviors. Finally, teaching attack is based on imitation learning, and it leverages the principle of learning by mimicking others' behaviors. We provide several biased examples to imitate and watch if LLMs act biased behaviors, both in bias agreement task and bias generation task. Now I will introduce our experimental setup. We evaluated 4 bias types in experiments, including age, gender, race, and sexual orientation. We tested 4 representative commercial and open source LLMs, including GPT-4, GPT-3.5, Mistral v0.3, Llama 3, and Qianwen 2. We choose attack success rate as our metric. We also adopt 10 repeated times for each instance. Following the given process, we transform the data from CVBQ dataset into biased dialogues. This is the main results we got. It can be observed that all of our attacks outperform baselines, indicating the effectiveness of psychometrics principles towards LLMs. Among them, deception attacks, including mental deception and memory falsification, are the most effective. Models can be separated into 3 safety tiers under our attacks, with the safest models including GPT-4, GLM3, Mistral v0.3. and the least safe models are GPT 3.5 and Llama 3. We also observed that more biases are revealed in mild bias types than severe ones. The possible reasons are: first, severe types are easy to recognize. Second, more IRHF are carried out on severe ones. For teaching attacks, we adopt bias generation tasks, and LLMs disclose other types of implicit bias. It highlights the existence of a wide range of inherent biases in them. For English and Chinese languages, LLMs generally induces more biases in efficiently supporting language. The possible reasons include stronger instruction following ability and more sufficient training corpora in these languages. We explored roles played in disguise attacks, and the results show that playing an involver makes LLMs more vulnerable. In mental deception attacks, LLMs can be given either a specific bias or a general bias, and results show that they are the same effective, with general mental deception easier to generalize. We built the Bumble benchmark for more comprehensive evaluation, covering 9 bias types. The evaluation results of GPT 3.5 on Bumble is also shown here, indicating the bias condition across various bias types. The benchmark is also applicable for other LLMs as well. In conclusion, we propose an effective psychometric-based attack framework to reveal implicit biases in LLMs via 3 attack methods: disguise, deception, and teaching. We find that LLMs exhibit significant implicit biases in both discriminative and generative tasks, with the extent of bias varying across attack methods, models, languages, and bias types. We constructed a bilingual benchmark Bumble to evaluate LLM's implicit biases in both English and Chinese. That's all. Thank you for your attention.